Welcome to the week 2 progress update of the project PRAXIS-9 that I'm building under the Eternal program in Solana. So, just to give a recap from what we have accomplished in week 1, we have been able to produce a working prototype for the core battle engine. So that involves turn ordering, action resolutions, statuses, skills, and the very basic components of the core engine or the core combat loop. So for now, as promised, we have enriched the AI combat decision-making system from basically reactive AI to a tactical learning system. So before AI chooses actions using simple scoring, and mostly it looks at the enemy, so it's just locked in to the enemy that it's fighting, and it doesn't plan ahead. It just stays on that specific turn, and it doesn't understand the situation. So it's basically just, it feels like a script rather than intelligence. When you run that same battle again, even if it's a different uh, enemy, it probably would still just do the same moves all the time. So the problem was it could not adapt, and it could not think tactically, and basically it cannot anticipate the enemy actions, or it cannot plan future moves. And the goal is to create an AI that understands the full battle simulation, not just the enemy, also the self and the greater battle context. And from those battle contexts, it can make tactical decisions, and more importantly, it learns over time. So as as the character battles more and more, it it develops a certain battle strategy based on the outcomes of every battle. And at the same time, the decision-making system is still deterministic, so it's replayable and debuggable. So the big shift was from hard-coded scoring rules, which is uh, pretty plain and shallow, to a layered decision system. So now the AI doesn't just react. Now the AI actually reasons, actually thinks of the most appropriate action. So to give an overview of the decision making system, of the layered decision making system. So this is basically the stack. So for now we have awareness. Earlier it only looks at the enemy, and now it sees itself. It sees itself, and it sees the enemy, the threat level of the enemy, and it sees the entire battle state. So actually it sees, for now it sees the round over the max rounds, for example. So it is now aware of that. And second, we have tactical signals. So instead of just hidden rules, it now evaluates the actions that's available to him or available to it regarding its damage potential, survival pressure, or it looks at setup opportunities. Like if I it thinks that if I use this skill now, would it uh, would it result to higher damage output later? Or it can also evaluate control advantages, like if the enemy is expected to use a high damage output skill or attack, it can use it can prioritize control skills, like it uses disables, stuns, or skills that prevent the enemy from doing that. So now that we have tactical signals, the decision making of the AI can now be explained. It's not just a uh, basic weight scoring anymore. It is now grounded by the tactics that the AI adopts. The next layer is intent. Now, before the AI calculates or computes the best action, it first decides why. Before it acts, it decides uh, how do we approach this round? Like, should I based on the battle context, should I just finish it? Just maybe the enemy is has only a little HP left, so I can finish the round now and choose the attack that has the highest damage output or has the highest success chance. Or should I try to survive because I'm waiting for the availability of my skills? Should I use defensive maneuvers, or should I use controls? Should I disable the enemy to reduce his effectiveness? Use disables, silences, and sustain the fight until there comes an opportunity to burst the enemy, something like that, or maybe set up a future advantage, like as I mentioned before, basically think thinks ahead for better performance or better outcomes. So now the behavior becomes situational based on the battle context, and it's not just purely static weight scoring. So the next layer is prediction. Now this is very important. This is actually what makes AI systems like this to emulate some kind of human thinking ability of predicting what's going to happen next. So now the AI predicts enemy action and it estimates incoming damage. It evaluates the impact of the next turn, things like that. It's very light for now. It just evaluates only one turn ahead. So it's doesn't plan ahead for maybe about 3 steps ahead or not. So for this iteration, for simplicity and for well shippability for this submission, I have decided to keep it light to only one turn ahead. So the next, probably the most important layer is the learning. So basically, the AI improves from previous battles. So it doesn't stay the same. It always changes depending on the battle outcomes. And from those previous battles, it develops a certain strategy towards combat as a whole, or towards enemy archetypes. It adjusts its behavior over time, and and one caveat for learning is it must be controlled, so it won't be there are guardrails to this, so it won't uh, it won't result to degenerate AI behavior. So it's still bounded and stable. So now the AI is not fixed and it evolves with experience. So the current iteration of the AI decision making system that we have applied is now context aware. Basically, it sees the whole picture. It's tactical. It has a tactical approach to it, and it's forward looking. It anticipates the impacts of the next turn, and it's learning based. So it's dynamic. So it's not that easy to guess the enemies or another player's uh, actions or decision making system, because uh, even if you had the same characters, if you're doing PvPs, even if you had the same characters, you had entirely different battles, uh, uh, historical battles. So most probably you're going to the characters are going to behave differently from each other, and it's still deterministic. So this is very important, so that moving forward towards the development, we can still manually check or debug the outcomes or the processes of how the AI does decides on the combat in the combat. So what's next for Praxis 9? We have produced a core battle engine for the week 1, and for this week 2 we have deployed a richer combat decision system. So for the week 3, what we are targeting is on-chain validation. So basically, since the battle engine is, the combat simulation is going to run off chain, we need to have sanity checks on the on chain part if we're going to persist some of its data. For example, rewards or battle outcomes or character progression like levels, uh, stat increases. So what we have in mind is that the data coming from the off-chain server simulation to the on-chain uh, data persistence is going to be filtered through certain specific sanity checks. Like if after that outcome the the server sends like an unreasonable amount of rewards or experience from that previous battle, we should have on-chain guardrails to prevent fraudulent transactions or fraudulent updates on the data. And after that, on the week for the last week of the eternal sprint, so we have the data persistence, which is basically requires on-chain validation first. So it's the last thing. It's going to be uh, the last deliverable for this Solana project. So thank you for listening and watching. See you on the next week progress update for the week 3 for the project PRAXIS-9. Thanks.